Hello everybody and welcome to this video. In this video we are going to see a brief overview about radar. Well, I'm sure right from your school days you must have heard about this word radar. Radar is basically an acronym which stands for radio detection and ranging. Now as the name suggests, there is radio, there is detection and ranging. Okay, the word radio depicts the fact or simple principle that radio waves are emitted from the radar and the same radio waves are received by the receiver. Now how exactly it is reflecting and how it is reflecting back, well, that's a slightly elaborate explanation is required, but for now you please understand radar works on the principle that radio waves in the electromagnetic spectrum are emitted from the radar and received from the radar. There are basically three types of radar which is used in automotive industry. Okay, when I say three types of radar, these three belong to automotive industry. Of course, there are other types of radars also which are used in various types of industries like industrial, medical, surveillance. A lot of other applications are also there, but strictly in the ADAS perspective, three types of radars are there. One is the short range radar, acronym is SRR, and this short range radar works in the range of 30 meters to 40 meters. And next is medium range radar, which has a span of 80 to 120 meters. And next is long range radar, which has a span of 250 to 300 meters, or at least most of the long range radars which are available in the market on mass production basis are available or working at a span of 250 to 300 meters. Some latest development in radars, they are advertising that they have radars up to a span of 400 meters also, but that they are still in the research phase, so let's not talk about it. So automotive radar works on the principle of frequency modulated continuous wave. Okay, and aerial radar works on the principle of pulse radar, which requires very high power. So please understand that automotive radar basically it requires very less power because the distances measured in the automotive industry are very less when compared to the distances measured in the aerial industry or air force or in air force, because in air force, which use the principle of pulse radar, the distances measured are usually in the hundreds of kilometers or thousands of kilometers, but in radar it is just around 250 to 300 meters maximum. So that's the reason it uses only frequency modulated continuous radar. Now, what is field of view? Field of view is nothing but the entire area, if I am talking about two-dimensional field of view, and entire volume if I am talking about the three-dimensional field of view. Now, see this, I just want you to see this drawing on the right side. Now, this and this, just if you imagine a triangle, it is just a horizontal field of view, but if you see a three-dimensional angle, okay, sorry, my okay, I know my drawing is not exactly very accurate, but I hope you are getting a reasonable picture. And this is the vertical angle. So how the field of view can be both two-dimensional and three-dimensional. Two-dimensional you can imagine like a triangle, a flat triangle, and a three-dimensional you can imagine like a pyramid or a cone, with the starting point or the pinnacle point starting at the point of origin of the radar. Now, just to give a brief idea, what are the various applications using this radar? You please see the, let me point out, yeah, you please see here, blind spot detection, lane change assist, cross traffic alert, forward collision warning, forward collision mitigation, rear collision warning, stop and go. All these are various features in which radar is extensively used. Now, if you see this drawing, you will get a clear understanding the diversified nature of the various radars that are being used in the market. So this one with a field horizontal field of view of 80 degrees is a short range radar, and as I have mentioned here in this drawing, short range radar has a max longitudinal range of 50 meters, and MRR, which stands for medium range radar, it has a longitudinal distance of 100 meters, and LRR, long range radar, has a distance of 250 meters. So these are all the types of radars that are mainly prevalent in the automotive industry. Now, just to understand what are the various properties of radar, what are all the various the radio signal which is coming out of the radar, what are the various properties of the radar, what are the various properties that can be measured with the radar. The first property is azimuth angle, which is a horizontal angle. I mentioned in the previous slide, it's nothing but horizontal field of view. Next is vertical angle. Next is Doppler speed. Doppler speed is nothing but other word for relative velocity. For example, if I am driving in a car at 80 km per hour and suddenly a car overtakes me at a speed of 120 km per hour, then what's the relative velocity? 120 minus 80, 40 km per hour. That is the relative velocity. And based on the relative velocity, it calculates the actual speed also. It calculates the actual speed also. But Doppler speed basically calculates the relative velocity, and it also calculates the distance, radar cross section. And automotive industry majorly works on 77 gigahertz to 81 gigahertz. Now, if I had made this presentation just 2 years back, I would have said there is one more frequency range called 27 gigahertz, which also used in automotive industry. But because of some legal regulations, 27 gigahertz has been not exactly banned, but many OEMs have stopped using 27 gigahertz because of some legal reasons. So right now all the OEMs are working with a frequency of 77 gigahertz to 81 gigahertz. On the right side you can see the various drawings of the radar. This is one type of radar, this is other type of radar, this is the pin. Usually the pin will be have several connectors, up to 10 connectors it has. One is for electricity, other is for ground chassis, other is for CAN or FlexRay or automotive Ethernet, depending upon the data protocol you are using. Now, who are all the major radar manufacturers? Well, you can see I have mentioned a list of automotive radar manufacturers here. Aisin, Psyche, Autoliv, Bosch, Continental, Borg Warner, Denso, Lunewave, Oculi, Urad. Now, this Lunewave, Oculi, Urad are very how to say infant industries. They have launched their products very recently. Okay, unlike established companies like Bosch and Continental, Loonwave, Oculi and Urad are very infant industries, and they have launched some proprietary technologies where they are claiming that these modern radars can have a field of view of 180 degrees and also a longitudinal distance of around 400 meters. But as I am talking right now, they are not exactly very popular, so they are not yet very much popular among the OEMs. Now let's see a brief exploded view of automotive radar system. Now this is the second generation long range radar and this is the third generation long range radar. This small plastic top which you are seeing, it is made up of hard plastic. It is called radar dome, or people in the industry who are very acquainted with this terminology, they call it radome. So radar plus dome, they call it radome. Okay, next comes the printed circuit board for processing and power supply. Now this printed supply consists of both transmitter and receiver, and the entire processing of the data happens here. Now next is the body. Body is made up of hard plastic. The second generation made up of hard plastic, but third generation is made up of aluminum. Okay, again here is the pin connector. As I mentioned, pin connector, I think here it is a 8 pin connector. Of course, it's not exactly very visible, but I'm just speculating, but most probably it's a 8 pin connector. Again, there is a radar printer board and a die cast back plane. Okay, here you can see these are all die cast aluminum, but the second generation it is hard plastic. So a transition from hard plastic to aluminum has happened when they shifted from one generation to next generation. Now I want all of you to pause the video and understand these drawings very carefully, so that you will understand the advantages of the radar and disadvantages of the radar. You will see very clearly if you understand this drawing where exactly radar is scoring well, and where exactly radar is falling apart. For example, here if you see, based on this diagram, depth of, when it comes to measuring the depth, radar is doing very well, but when it comes to resolution and classification, radar is very poor. But for measuring the velocity, it is doing very well. it is weather independent, because radar, irrespective of the snow, fog, mist, dust, radar can work very well. And even this daylight independence, it is independent of the daylight, there also it is working properly. Now in this drawing again you see that range, it is working well, speed detection, it is working well, but 3D classification, it is faring very poorly. Measuring, identifying the color, it is very, it is actually 0. It is not even faring poorly, it is actually 0. If you see this drawing, if you see this drawing on the right top, again you will understand when it comes to sensor cost, it is very advantageous, range is very advantageous, it works in the dark, it works in the bright, works in the snow. I mean, these are all the areas where radar has a huge advantage. Now it detects speed, again huge advantages. Sensor size, very advantageous, because sensor size is very small, it can be fitted right behind the bumper without spoiling the aesthetics of the car. Without spoiling the aesthetics of the vehicle, the look of the vehicle, radar can be fitted right behind the bumper, so that it is not visible to the outsider or a common passenger. Now let's briefly touch upon the advantages of the radar, which I already outlined, but let's do it in a more systematic manner. Advantages of radar in ADAS. Radar sensors are much better at detecting moving vehicles, pedestrians and other objects than cameras or lidars. They can see objects that are far away and moving quickly, which is why they are great use in many ADAS. Radar sensors also work well in all weather conditions, including rain, snow and fog. This is something which I outlined already. But what are the disadvantages of ADAS? Based on this drawing, you can understand that when it comes to resolution, it is faring pathetically. It comes to classification, it is faring pathetically. When it comes to color, it is faring pathetically. Now, these are all the disadvantages of the radar. The radar sensor has a limited field of view. In some situations, it may detect the vehicle later than expected or not at all. So sometimes it happens that the detection of the vehicle can happen a little bit late. This can be prove very detrimental to the entire operation of ADAS. Now the radar sensors detection of vehicles very close to your vehicle may be delayed in certain situation. Example, if a vehicle pulls in between your vehicle and the vehicle directly ahead. So in certain situation, if a vehicle suddenly enters the vehicle, enters the gap between vehicle and the vehicle ahead of you, then the detection of the vehicles very close to you can be slightly delayed. Now these are all the disadvantages of the ADAS. Now what are the major features that are using radar? Adaptive cruise control, it is using LRR, front cross traffic alert, SRR, blind spot detection, SRR, rear collision warning, SRR, emergency braking, MRR. Emergency braking, sometimes they use SRR also, depending upon the velocity of the car. For example, it's a very premium car, high-end sports car, they can use MRR. If it is a ordinary sedan, ordinary family car whose the top velocity is very mediocre, then it can just go with SRR also. Now collision avoidance, MRR, pedestrian detection, MRR. Now these are the various features that are used by the that use radar predominantly.